These are the test corrections for the Pre-Calc Chapter 5 test taken May 13th, 2019. This is versions A and E for my daughters Autumn and Eloise. If you recognize some of the problems on your test, hopefully you recognize they actually came from last year's test. This version right here came directly from last year's test. Didn't even touch it. So if you actually did last year's test as a study guide, hopefully it helped you. What I did is I just went over on this side here, and then I actually just did all the problems, and then I just matched up my answers. And if you have your formula sheet nice and handy, super helpful. Alright, so I see a negative angle. That's called the negative angle identity. The sine of the negative angle is equal to the opposite of sine of theta. So if you have sine of negative 35 degrees, that means it's going to be negative sine of 35 degrees, and that would be choice number 2. So 2 would be A. B says cos, sine, sine, and then you have the minus sign. So this is cosine, and this is the sum identity of cosine. Remember, C for cosine means to change the sign. So this is your A and this is your B value. So this would be A plus B, so you would have cosine of 45 plus 30. Remember, that's your A and that's your B. So cosine of 45 plus 30 would give me cosine of 75. And that would be the first one here. Cotangent of 50 degrees, there's a couple of ways you can think about it. You can think about the reciprocal identity, or you can think of a cofunctions. Cofunction identity. Cotangent of a theta equals tangent of 90 degrees minus the angle. So if you were given 50 degrees, cotangent of 50, then that would be tangent of 90 minus 50. And then 90 minus 50 is 40. Tangent of 40 degrees, so that would be this one down there. For D, I see sine, cos, cosine. I see a sandwich of the S's. So this would be sine. The sine is like a sandwich, so the sines are on the outside and your cosines are in the middle, and then S also stands for same, so this would be a plus. So this would be A plus B. This is your A, this is your B, A and B. So then you're going to have sine of 45 plus 60 degrees, which would give you sine of 105 degrees, and that would be the fourth one. E here I have cos, sine, sine. So this is the cosine identity. Remember, C means change, so this would be a minus, A minus B. This is your A, this is your B, this is your A, this is your B. And so I have 150 minus 90. And that would give you a cosine, no, 60. And that would give you a cosine of 90 degrees. But I noticed that cosine of 90 is not on here, so this one is not used. All these were used. Cosine of 75 degrees. Notice how there is no extra things on here like cosines and sines, so it's not a sum or a difference identity. Here it's going to be a cofunction. Cofunction identity. So cosine of theta equals sine of 90 degrees minus theta. So if cosine is 75 degrees, then it would be 90 degrees minus 75. And 90 minus 75 gives you sine of 15 degrees. And this is on there, so this would be choice F. And although you might be tempted to just put the last letter there, just work it out. Cos, sine, sine. So you have a bunch of these. You should recognize the, so if you get stuck on just identifying those, at least can you put your A's and B's there? Can you put your cosine? So I got the formula right there. Do you guys see it? And then you should be able to match it up on your formula sheet that your A and your B values, here you're going to be doing a plus sign. So cosine of A plus B. And your A value is 150 and your B value is 60. So if you add those together, you get 210 degrees. So this would be G. Those are 2 points apiece. We skipped question number 7 there. And then question number 8. So one way why you might be paying attention is that the other version of this test that you didn't take is actually a study guide, right? Other problems. So you're supposed to fill in the blank with something. I have cosine squared theta equals 1 minus something. So I see a 1, I see a cosine squared. I'm thinking my identity, that's going to be the Pythagorean identity. I'd probably say the number one mistake on the test is not knowing your identities. A lot of students thought sine plus cosine equals 1. That's incorrect. It's sine squared plus cosine squared equals 1. And so I want to get cosine squared by itself, so I would subtract sine squared from both sides. And then you're left with cosine squared equals 1 minus sine squared. So right here, to get full credit, I would have to write sine squared theta. Question number 9, I have the cofunction identity here. Again, you can write the formula right below it, super helpful. Cosine of 90 degrees minus theta equals, that would be sine. So the identity on your formula sheet is actually right there, right? Direct, don't have to even change it. Question number 10 says sine squared theta minus 1. So here, I'm going to use the Pythagorean identity. It says sine squared minus 1. So if I write this, sine squared plus cosine squared equals 1. How do I get the 1 over here? I would have to subtract 1. Let's put it right there. How to get rid of this cosine? You would just subtract cosine. Subtract cosine. So then 1 minus 1 is 0. Cosine squared minus cosine squared is 0. And then you're left with sine squared equals sine squared minus 1. There's a minus 1. Equals negative cosine squared. So your answer here to get full credit is negative cosine squared theta. The number one common mistake there is just to write cosine squared. You would have gotten 0 credit. Another mistake students wrote is they thought this was a double angle identity. And number 11, I just see sine over cosine. This is the quotient identity. This is tangent of theta. So 2 points apiece. Question number 12, solve the equation on the interval. We've talked about that it is bad. I give you guys a warm-up. And in the warm-up, the problem was x squared equals x. And the question was, how do you solve that? It's bad if you divide by x on both sides, because you would only get one solution. What is the good way of doing this problem? You subtract x from both sides. You get x squared minus x equals 0. You're always solving quadratic set equal to 0. Here you can factor out an x. And then if you set each of those equal to 0, you'll notice that you have two solutions, x equals 0 and x equals 1. So this applies to this problem. You should have not divide both sides by sine of x, because then you would only be left with one solution. So you're going to subtract sine of x from both sides. 2 sine squared x minus sine of x equals 0. I notice some students are still struggling what sine squared x means. So kind of algebraic friendly or student friendly is 2 sine of x squared, right? You have sine times sine. That's what it means. And then here I can just factor out a sine of x. So I'm left with 2 sine x minus 1 equals 0, just like the problem over there, and then we're going to set it equal to 0. Sine of x equals 0. 2 sine of x minus 1 equals 0. I'm going to add 1 here. 2 sine x equals 1, divided by 2. Sine of x equals 1/2, and sine of x equals 0. You can take the inverse there. So you get the inverse of sine of 0 equals x, and you get the inverse of sine of positive 1/2 equals 0 equals x. So the question is, where is sine positive 1/2? Okay, I know that sine is positive in these two quadrants, right? If I do my counting technique, 1, 2, 3. This is the first order pair, that is cosine. The second pair is sine. So then you count back up, 1, 2, 3. So my 1 cosine is 1/2 here. This would be pi over 6. So pi over 6. And then on this side, and this, because here it's negative, again 1, 2, 3, 1, 2, 3. So that would be right here. So this is 6 pi over 6 because this is pi. And so one before would be 5 pi over 6. Then where is sine 0? If we did an order pair here, it would be 1, 0. So that's cosine sine. So sine is at 0. And then over here at this order pair, negative 1, 0, cosine sine. Sine is 0. So that would be at pi. So our two answers would be 0 and pi, and then 5 pi over 6 and pi over 6, and that would be choice D. And that side was out of 24, because I didn't count question number 7. Turn to the back side. Use the fundamental identities. That's Pythagorean, quotient, and reciprocal identities. Or basically it tells you again to write the expression in terms of sines and cosines. So if you change them into sines and cosines, I gave you 2 points even though you didn't multiply. The first thing you need to do is multiply. How do you know to multiply? It's kind of like 1 plus x times 1 minus y, right? Here you cannot just multiply the first terms and last terms. You're going to use something FOIL or use the box. I'm going to show you the box. And I'm just going to write 1 plus secant theta. Let me go ahead and draw another box. And if I was doing this problem, 1 plus x and then 1 minus y. So that's 1, this is 1x, this is negative 1y, and then when you multiply these together, it's negative xy. So when you're multiplying over here, you'll get 1 negative cosine theta, 1 secant theta or secant theta. Remember, you don't have to write the coefficient 1 in front. And then this is a positive times a negative, so that's negative. And it doesn't matter which trig ratio you put in front. So then when I write out all of these terms, I have 1 negative cosine theta plus secant of theta, and then negative secant cosine of theta. Remember, when you're using FOIL or this box method, what we did there is we multiplied first, and now we're trying to combine like terms. You'll notice that none of these are combined like terms. This is just a cosine by itself, this is a secant by itself, and these are together. Now I might want to change them into sines and cosines. So I have cosine of theta plus 1 over cosine of theta minus secant of theta is going to be 1 over cosine by the reciprocal identity, And then I'm putting in parentheses because it's multiplication here. So here was a common mistake among students. They would try to cancel these right here. And the reason why you can't cancel those is because they're not factors. They're called add-ins. What does that basically mean? You have addition here, so you don't cancel there. It's like a fraction. You don't do 1/2 plus 2/4, you don't sit there and cancel your 2's. Okay? Now you can cancel over here by multiplication, so you could cancel these cosines. Now when you cancel over here on this side, all of that becomes what? -1. Pay attention when you're canceling. It's either going to be 0 or 1, right? Then I have 1 minus cosine of theta over 1 plus 1 over cosine of theta minus 1. So here I have a +1 and a -1. Now I'm left with negative cosine of theta plus 1 over cosine of theta. Now I'm adding. When I'm adding, do I multiply by the conjugate? No, this is a common denominator. What does that mean? This has a cosine, this one doesn't, so I'm going to multiply this side by cosine over cosine. What is that going to get me? Negative cosine squared theta over cosine of theta plus 1 over cosine of theta. Now if you look at this, now I have a common denominator, so I have negative cosine squared theta plus 1 over cosine of theta. This one looks like something I can use. That is the Pythagorean identity. Notice it says negative cosine, so if I do sine squared plus cosine squared equals 1, and I want it to be negative cosine, so I would subtract negative cosine. And to get sine squared equals 1 minus cosine squared. So in this problem, this is going to become, running out of space, so I'm going to get sine squared is sine times sine. Would you guys agree? Over cosine of theta. And then this one right here, sine over cosine is going to become tangent. And this one is just sine. So the answer for that problem is tangent of theta times sine of theta. Again, if you change them into sines and cosines and like you didn't multiply, I at least gave you 2 points. That was a very merciful second point, I think. If you got down to at least these 4 terms and you were trying to simplify, somewhere in here I give you 3 points. And then I give you 4 points if you had that one correct. Question number 14. I'll probably get halfway through number 14 and then I'll just report it 4th period. Use the sum and difference identity, so it's telling you what to use, right, to find the exact value of cosine of 15 degrees. In this problem, if you just wrote out the sum or difference identity for cosine and it was correct, I give you 2 points. Okay? It says cosine of 15. 15 is not in your unit circle, so you're going to have to think of 2 numbers. Well, my encouragement is always focus on quadrant 1, so cosine of 45 degrees minus 30 degrees. This would be your A and your B value, so I would have cos, sine, ob, change the sign. And then I can just do a substitution for those values. Cosine of 45 degrees times the cosine of 30 degrees plus sine of 45 degrees times sine of 30 degrees. And this is where you need to know your unit circle. Notice you kind of struggled all semester long. It's probably your understanding of the unit circle. So here's quadrant 1. 45 degrees is the middle notch. The order pair here is 1, 2, 3, 1, 2, 3. So I have radical 2 over 2 for the 45s. Same thing on this side. Cosine at 30 is going to be radical 3 over 2. And sine of 30 is 1/2. So if I multiply across, you get radical 6 over 4. And if you multiply across here, you're going to get radical 2 over 4. You have a common denominator, so you're going to have radical 6 plus radical 2 all over 4 as your answer. Partial credit I gave in this problem is if you just wrote down the formula and you did your substitutions, I gave you 2 points. If you used the unit circle correctly and you're still using these values and maybe you made a mistake, right? A common mistake was just writing it over 2. Then I took off a point. And that's question number 14. Alright, so I'm on versions A and E now. Just a reminder that the test was out of 40, not 42. The reason why is I skipped question number 7. Okay? There are some errors on one of the versions. Question number 15. Given cosine of alpha equals 1 over radical 5. I don't know why students get scared of the radical, so they only just wrote 1 over 5. And alpha is between 0 and pi over 2. Find the exact value of tangent of 2 alpha. So there's a couple of ways. In here it doesn't tell you you have to use identities. I'd rather just show you my solutions to go faster. One way you can do the problem is just find tangent, because tangent, the double angle identity for tangent, the answer is tangent to alpha equals 2 tan alpha over 1 minus tangent alpha squared. Well, I need tangent, and I don't have tangent. So how do you find tangent? Well, I know that cosine is x over r. Use the Pythagorean theorem. Radical 5 times radical 5 is radical 25, which is 5. 1, subtract, and you get y equals plus or minus 2. Now it tells you you're in quadrant 1, so your y value is going to be a positive 2. From here, then you can get tangent to be y over x. So tangent is tangent of, what does that say? Tangent of, that's tangent, of alpha equals 2. So if you got tangent equals 2, I gave you 2 points. What's another way of finding tangent? You can use the Pythagorean identity. Sine squared plus cosine squared equals 1. Cosine is 1 over radical 5. Multiply this by itself, so that becomes 1 over 5. And if you subtract, that's a plus. 1 over 5, you get 4 over 5. You take the square root. Square root of 4 is 2. Square root of 5 is 5. So sine is 2 over radical 5. Notice here I didn't rationalize because you don't need to until it's a final answer. And another way of finding tangent is using the quotient identity. Sine over cosine. Sine is 2 over radical 5 divided by 1 over radical 5, which is your cosine. Change that to multiplication. Take the reciprocal of the second expression, and then you can cancel your radical 5s, and you'll find that tangent is equal to 2. If you wrote down the formula for the double angle identity of tangent, then I at least gave you 2 points. Substitute in tangent to be 2. This becomes 2 times 2, which is 4. Here you have 2 squared, which is 4, then 1 minus 4 is negative 3. So tangent of alpha, tangent of 2 alpha equals negative 4/3. Question number 16. Verify the identity. When you're verifying identities, you only work on one side. You can choose either the left or the right. Because you have an equal sign, This is where I multiply by the conjugate. The conjugate is 1 plus sine x. When you multiply these two, this is a difference of squares. This is where you would get 1 minus sine squared x, or 1 minus sine x squared. Here, don't distribute, but you can. Wouldn't be wrong. 1 minus sine squared x is a variation of the Pythagorean identity. Cosine squared equals 1 minus sine squared. So this here becomes cosine squared. And cosine squared is just 2 cosines. Cancel, and you're left with 1 plus sine of x over cosine of x. Now, if you just multiply by the conjugate, or you at least wrote that down, I'll at least give you partial credit. To work on the right-hand side, it's basically the same thing. I'm going to multiply by the conjugate, but the conjugate on the right-hand side is 1 minus sine of x over 1 minus sine of x. When you multiply here, this is a difference of squares. The middle terms will be eliminated. Use the Pythagorean identity. You have 2 cosines, cancel, and then you've verified the identity. The extra credit questions were self-advocacy. Being a self-advocate. You step up for yourself. And then the other classes was 1961. So again, the test was out of 40.
I love math. You don't love math? What's wrong with you?